Welcome to Simpler Than You Think, an insider's look into EverestLabs AI and robotic installation. Before we get started, I want to go over a few things. First, everyone is on mute. Second, we are going to be recording this webinar and we'll share it with you afterwards to watch again or to share with your colleagues. And we're going to be having some live Q&A at the end. So if you have any questions throughout the presentation, feel free to drop them in the Q&A box at the bottom of your Zoom window. But most importantly, enjoy. So I'd like to welcome our presenters, Catherine Nellis, Solutions Engineer, Samir Kamat, Lead Solutions Engineer, and Ratik Reddy, Robotics Deployment Engineer. All right, Catherine, let's get started.
Thanks, Sam. So today's agenda, I'll first take you through what we do at EverestLabs and what we offer. Then Samir will overview how a site survey works and why they're important. Ratik will come on and we'll give him some questions so we can give you that look into our AI and robotics installation. And then we'll finish up with a live Q&A. Next slide. So RecycleOS encapsulates the products that EverestLabs use to help automate all different plants in this industry. Our high quality vision system captures a 3D video stream of all the material on a belt. We then leverage a proprietary data set of billions of recyclables. So our AI model can identify and classify over 30 general material types with more than 95% accuracy. And these material types are pretty general. We can specify and classify new types based on individual needs. And we're adding to this all the time as we expand and work with more brands. All of that captured data is then available to our clients through cloud-based dashboards. You can track all sorts of materials like plant performance, robot performance, material composition, costs for landfill, sale quality, etc. And we provide some standard dashboards that can configure them to your needs and even set up automated reports for you to receive at your convenience. The AI and data allows our clients to make data-driven decisions on how to improve their plants. And a great way to reduce labor costs and increase recovery is through our EverestLab robotics. These robotic cells are designed to take up as much space as a human sorter and can be installed in existing belts, whether they're inclined or cleated. And as you're going to learn more through this webinar, we install safety cages in a small way to not disrupt your existing spaces. And the robots don't have any screens or filters to clean, so maintenance is very quick and minimal. Along with our robotics comes monitoring from our robotics operations center. Next slide. So this ROC provides 24/7 monitoring for your solutions that are in production. We do continual audits, keep track of robot performance, and will alert you if anything is off so that we can perform remote troubleshooting and work to resolve it. We also provide auditing of the AI models over time to make sure it's maintaining its accuracy. Essentially, the ROC just eliminates downtime and the need for our clients to have to babysit their robots. Next slide. So to sum up the differentiators about EverestLabs and about RecycleOS, it's simple. You know, our small footprint of cameras and robot can be installed without retrofits. Dependability comes from that robotics ops center, which guarantees robot uptime and performance. We're precise in that our AI and imaging is top of class, and we're continually improving it as we grow that database. And lastly, and most importantly, our payback periods for plants is impressive, often anywhere from 3 to 6 months. And a large part of that is our ability to get installation done quickly and efficiently. So that's a bit about EverestLabs and what we have to offer. But how do you get there? How do you get to that level of automation and payback? I'm now going to pass it off to Samir to take you through what happens next.
Thanks, Katie. From start to finish, it's really a matter of a couple of weeks with no downtime. We start with a site assessment where we understand your pain points and do a bit of discovery to really gather more information on the processes run by your plants and what kind of AI or hiring needs you may have. Based on the site assessment, we dial down to a few conveyor lines where we think would be a best fit for our vision system based on the pain points you described. Takes about a day to perform site assessment, about a day to install our vision, and then right from day two, the data is ready to be collected and determine what the pick strategy for the robot should be. The robot arm and the cage installation itself can be done over a weekend, so it really doesn't require any kind of downtime at the facility. This is usually we come in on a Friday evening and the robot is up and running on a Monday morning. Once the vision system is set up and the data is collected, then we provide access to the Recycle OS platform for our customers to start using data and really start monitoring their lines and get more understanding on all the different kinds of material they see on these lines. Next. So let's take a look at how site surveys work. This is a MRF in the United States that reached out to us because they had some staffing challenges. They were looking at automating these two positions with two robots so the two sorters could perform higher value jobs at a different location within the facility. Next slide. So we went in, using our tools, we got some measurements around the belt. We got a 3D point cloud of what the conveyor belt looks like. And we were able to obtain all the dimensions, the belt speeds, and all the parameters that were necessary for a successful install. After we got that, we dropped our 3D models of our vision system and our robotic systems on the line. And this way, we were able to exactly communicate with the client on what the drop positions need to be, where the robots would get installed, and more importantly, what the egress would look like after the robots went in, and to make sure that the sorters and the staff in the facility had enough space to walk around the robots after they went in. Next slide. After the robots were deployed, the real value proposition for these systems were that each of these robots could do up to 60 picks per minute at greater than 80% efficiency. The MRF was able to address their staffing challenges. In addition to that, they were able to run more material more quickly. And also by automating this line with two robotic systems helped them replace two human sorters, helping them save over $50,000 a year in labor savings.
Thanks, Samir. So now let's talk about deployment. And to do that, I've put some questions together for our deployment engineer, Ratik. So I'm a MRF manager and I've ordered an EverestLabs robot. What happens first?
Hi, Katie. Hi, everyone. So the first step in the EverestLabs deployment process is our team reaching out to the customer to set up a meeting. The purpose of this meeting is to discuss the initial installation layout plans, the requirements in terms of air, electricity, internet, and just getting to know the customer's team. That is the first step in the deployment process.
Great. So installing a robot for someone who's not familiar with EverestLabs can sound like a big ordeal, and we all know that MRFs can't afford to not run for a week. So how does EverestLabs work around that?
Our team here looks to minimize or eliminate any sort of downtime for our clients. We look to install over weekends or maintenance hours. Robot installs typically are done over a weekend. It takes about 2 days, and vision installs take a day. We tend to keep these on weekends, and if not possible, we do it on the maintenance hours of the customers. So we are extremely flexible in terms of working around our customers' schedules.
Fantastic. How does it actually work once you're on site? Do you just show up and plug everything in?
It's a little more involved than that, but it's pretty straightforward, our install process. So we generally tend to have some pre-installed work done by the MRF before our team arrives on site, which is the electrical outlets, air, and internet. Once these things are in infrastructure, things are in place, our team arrives on site first for the vision install, which involves mounting a vision system frame across the conveyor belt. And this frame has a camera attached to it, which identifies and detects all the materials on the belt. And we also have a computer system that is installed with the vision camera. So as you can see in these images here, on the left, we have a vision system, and on the right, we have our computer box and some of our other component boxes. And for the robot install, we have a robot pedestal, which is installed. The robot is mounted to this pedestal. You can see it in the left image over here, the blue stand. And we also have a safety cage which goes around the robot to ensure no one can access the robot while it is functioning, to prevent any sort of injury. So our safety cage footprint is generally quite small. We keep it extremely compact, minimizing the amount of space that we take. Next slide, please. As you can see in this video here, this depicts our typical robot cell. You can see the robot mounted on the pedestal, the vision system, the safety cage around it.
Great, thanks, Atik. So it's great that, our EverestLabs deployment team is on site as the experts during the install, but what happens when you're done?
Another great question. So I know a concern a lot of customers might have is that, these robots might need a lot of maintenance work, or you might need to babysit them. But our robots really require an extremely simple and easy maintenance, which is switching out suction cups and cleaning the end of arm tool. We have a video to sort of depict that. If we could go to the video, please. So I'll walk you through our maintenance. So it's extremely straightforward. You put the robot into maintenance mode, unlock the cage, as you can see here in this video, and we use a bottle brush to clean the end of arm tool. This is basically to remove any sort of gunk or any material buildup. Since our robot uses air, suction, and blow off to pick and drop materials, it's essential that the end of arm tool is clean. It's extremely easy. You can do it with a bottle brush. And now you can see switching out a suction cup. You just need to pull it to remove it. And then it's a little push and twist to install a new cup. And basically these cups are switched out when you notice a rip in the cup or you notice that it's worn out. It's extremely straightforward. Apart from this, we also provide on-site maintenance teams with some basic training post-deployment. And we also provide them with a basic maintenance kit. We have a customer support chat, which is set up so that our customers can reach our team extremely easily. And we also have our robotics operations center that monitors the robots 24/7.
Awesome. Looks simple in that you don't need to have like a robotics expert to go in there and put those on. So this last question, actually, I'm going to give to Samir. How are our clients seeing payback so quickly with our robots? Like, how soon after installation am I going to start seeing optimal recovery?
Yeah, so after the robots are installed over the weekend, the robots are 80% functional on Monday morning. Over the course of next couple of weeks, the robots are tuned to 95% plus accuracy by training and fine-tuning on our Recycle OS platform.
Thanks, Catherine, Samir, and Ratik. We really appreciate your time on this. I'm going to be opening this up for Q&A here in just a few minutes, but before we get started, if anyone wants to learn a little bit more about EverestLabs, you can go ahead and scan that top QR code, which will take you directly to our website. The second, I know that we ended this webinar talking a little bit about our payback period, but we're actually going to be doing a deep dive into that next Wednesday, February 28th, with Recycling Today on how does a recycling plant achieve a 4-month payback on AI and robotics. If you scan that second QR code, you'll be able to get registered for that webinar. And if you know you're not going to be able to attend, but you'd still like to learn more, you can still register and we will send you a link to the recording once it's done. Lastly, below is our contact information. So if you'd like to get in touch with us, feel free to jot down those email addresses and reach out. All right, let's get started with some Q&A. Great. Awesome. Let's all turn our cameras on. That was really good. I hope everyone that was listening enjoyed that. So like we said at the beginning, if you have any questions that you'd like us to answer, go ahead and put them in the Q&A section of your Zoom window. I do already have just a couple that have come in. And so let's see here. The first one is we've had experience with other robotic vendors where over time the robot pick performance degrades. Why should I believe yours isn't going to do the same?
Yeah, so I can take that one. So the Robotic Operations Center that I mentioned earlier is how we're able to guarantee our robot's performance over time. We keep track of the pick success rate, we keep track of the system being up and running, and we can set alerts or different thresholds for if that dips for whatever reason, and we send those alerts out to notify you or the necessary parties. If it's something that actually, we can do some remote troubleshooting to fix it. But some of the typical things that you may see are like cup wear and tear, and we actually provide the suction cups. So we encourage our clients to, perform that maintenance and replace them often to make sure that the robot's up and running all the time.
Awesome. Thanks, Katie. Here's another question. Are there materials that you feel the robot picks most effectively?
Thanks, Sam. Yeah, so we are pretty good picking up plastic containers, anything from PET, HT, PP5. So usually any plastic containers, we are pretty good at it. And now we are expanding our offerings to looking at expanding our offerings into other materials as well, such as cardboard and batteries and fire extinguishers and so on. And then we are also good at picking, going on metal lines, especially on aluminum QC lines. And, we do that all the time.
Great. Thank you. What is the actual benefit to me doing a site survey first?
Yeah, I mean, as Samir mentioned, it's incredibly important. It really just allows us to get out to your plant, to your site, see what you're doing and really understand it. We love coming in and touring the whole place and seeing what you're doing. It really just allows us to get a better grasp of how your operations run, where there's leakage or gaps that we can fill, and it allows us to come back with a really educated recommendation for a solution.
And then it looks like we have let's see, another one here. So how do you address extreme weather, especially the cold? So like in the Midwest, when temperatures drop significantly, do our robots still function with the same capacity? And how do we tell our clients to manage that?
Yeah, so we have engineered our system to sustain extreme weather conditions. Over the past winter, we have had systems deployed in Minneapolis, Ohio, as well as in New York, and they've recorded an uptime of over 98%. Similarly, we have air conditioning units installed in all our compute boxes that allow us to scale in warm environments as well. Some examples could be Fresno, California, Las Vegas, where we have our systems deployed and they're performing at their peak efficiency.
Great. This is an interesting question. I'm not sure how we can answer it, but someone is asking, does our vision system, what kind of plastics does it identify, especially microplastics? I guess that would be a Samir question.
Yeah, I think we'll need some more information on what the microplastics actually mean. So, Sam, if possible, we'd like to get in touch with them to understand different kinds of material and maybe dive a little deeper into the world of microplastics.
So the person who asked that, I just sent you my email address and we can start that conversation.
Awesome.
So we have another question here. It's kind of a handful, so I'll go down one by one, and this would probably be Samir or Ratik. So what is the estimated space that's required?
So any place where you can put a human sorter is where we can deploy our robots. And essentially, to put a robot cell, we need no more than 3 by 3 by 7 feet of space.
And are there any sort of width or speed belt requirements or limitations?
So our systems can perform effectively up to 220 feet per minute. And as far as the width of the belt is concerned, we can go on belts of up to 3 feet with one robot. And if it's any wider than 3 feet, then we just put two robots side by side to cover the entire width of the belt.
And then what's sort of the requirement or the space that's needed between items picked? I suppose that might go along with what you were just saying. If they're really close together, there might be room for double robots.
Yeah, so we can set some software and hardware limits to really optimize that space. But space between like really we typically we have put robots and human sorters side by side, and effectively that's been like within 3 to 5 feet of space.
And what are the power requirements?
So we need 220 volts for the robot and 110 for our regular vision system units.
And so is the software on a local PC or is Wi-Fi required to go online?
So all the compute happens on the edge. The edge sits next to the vision system, next to the compute boxes in your facility. Although all we ask is we do need internet, so we would ask you to provide us with an Ethernet drop so we can connect that to our system.
So basically one vision is installed over a belt per two robot arms. So I think what this question is saying is, I guess another way to put it is how many robot arms could go with one vision system?
So we can add as many. So we typically install two vision systems side by side, and we power that. We power that to our robots. So that's something that we can look at after we have taken a look at the belt and see what we are trying to pick, and after we get a better understanding, we can definitely make more suggestions and kind of optimize that.
Yeah, I'll add to that we do, you would normally think like one vision system, one robot, which is a common setup that we do, but we have also done like one vision system, multiple robots. But like as Samir said, it's a case by case basis for putting that together.
And then outside of changing of the suction cup that we recommend, is there any other preventative maintenance that we recommend?
No, I think all of that has been covered in the video that Pratik described, where all we ask is to just clean to the end effector using the bottle cleaning brush and just replace the suction cup with a new one. And we provide all those suction cups to you. So we ask that you generously replace them as and how you see fit.
Then this person's asking, do you have a basic dimension CAD DWG available?
Yeah, absolutely. We can share some. We can pass around some drawings that you could look at.
And I think we have one more question, and then we'll go ahead and wrap up. Do you ever start with installing a vision system on lines to determine if the line is good for a robot?
Yeah, so we typically ask that we look at when we do the site survey, we finalize a conveyor belt on where our robots could go best, and we typically start with deploying a vision system on that particular line, and we gather data, and then we work with your team on further determining what that best position for the robot is, and what would the what would the robot pick, and where its drop points be. So that is something we work with you after we have collected all the data from our vision system.
Okay, awesome. All right. Thank you everyone for joining this webinar. Thank you, Catherine, Samir, Ratik, for putting this on. We really appreciate your time. I hope everyone found this informative.